All right, guys, time for the day 2 area challenge review. I know you're loving these problems. There's a lot going on. We're going to read carefully. We're going to remember what formulas we have. We're going to plug in correctly. We're going to manipulate correctly. We're going to do a really good job. So the first question is an equilateral triangle that has a height. That's not an apothem. That's not a radius. That's a height. So if I draw my equilateral triangle out, I know that doesn't look perfect. It's the height that is 12. Well, on an equilateral triangle, the corners are 60 degrees. So when we drop the height, it splits it into 30 and 30. And I told you guys, let's get really good at equilateral triangles. We're going to see them a lot. We need to know how to navigate. So basically, we have a 30, 60, 90 triangle that we're working on that has a long leg of 12. Well, how do we go backwards from that? We need to do 12 divided by the square root of 3, which is 4 root 3. So the goal is the area of the triangle. So if this is 4 root 3, then the entire side is 8 root 3. So the area of the triangle is 1/2 times the base times the height. Well, half of 12 would be 6. 6 times 8 would be 48 root 3. And that is our answer, 48 root 3. Next problem, a regular polygon has 24 sides and a perimeter of 168 feet. Go watch my video on regular polygons if you don't know how those work, but it's the same steps every time. You draw one right triangle, you get the angle at the top. If there's 24 sides, if n equals 24, then there would be 48 of these triangles. So we do 360 divided by 48. So 360 divided by 48, and this angle is 7.5 degrees. The perimeter is 168. It has 24 sides. So if the perimeter is 168, if I do 168 divided by 24, that's how long one side is. But I don't have a side, I have half of a side. So I actually need to divide it by that answer by 2. So really we're doing 168 divided by 48. Again, we have 48 of these triangles. This would be 3.5. So this is our situation. We have 48 of these triangles. So the perimeter is cut into 48 parts. And the angle at the top is cut into 48 parts. And I need the apothem. I'll call it A. So this would be the tangent of 7.5 equals 3.5 over A. So A equals 3.5 divided by the tangent of 7.5. All right, so that's the area of that's the apothem. So the area of the triangle would be 1/2 times the base. I'm going to make it as a fraction. It's easier to work with fractions, 7/2. And by the way, let's look at this real quick because people are confused by this. This would be 7/2 over tan 7.5, which is the same as, you can swing that 2 to the bottom, 7 over 2 times the tangent of 7.5. Okay. So this would be 7 over 2 times the tangent of 7.5. Now that's one triangle. How many of these triangles are there? What did we just say? There are 48 of these triangles. So if I was trying to do this in my head, and a big part of what I want you doing this unit is really practicing that mental math. You could even think of it as a big fraction. The numbers on top are 1 times 7 times 7 times 48. The numbers on bottom are 2 times 2 times 2. Well, we can do 48 divided by 2. That would be 24. We can do 24 divided by 2. That would be 12. We can do 12 divided by 2. That would be 6. The 1 we don't really care about. So really we just have 7 times 7 times 6. So that would be what? Might be easier to do 42 times 7. That would be 280 plus 14. That would be 294. Don't forget, it's over tangent 7.5. Now, it says round to the nearest tenth, so I'm going to type that in. 294 over the tangent of 7.5. And I get 2233.2. 2233.2. Now, I did some crazy mental, or I was writing it out, but I was reducing and doing some funky stuff. If you just couldn't follow that, you could have just typed this into the calculator for right now. But honestly, you need to be practicing understanding what I'm talking about there. You really do. But our final answer would be 2233.2. All right, here's a fun one. There's a few, and just for the record, every one of these questions has multiple ways to think about it and do it. So I'm showing you, one way, maybe two. It doesn't mean it's the only way. So if you get the same answer I do and you got there a different way than I do it, that is fine, as long as you have work to support it. So the area of the sector is 100 pi, and it says the area of the circle is 900 pi. So there's a few ways to think about this, but let's do it algebraically. So the area of a sector is pi r squared times the measure out of 360. So we know the area of the sector, that's 100 pi. We know this. Isn't 900 pi, isn't the area of the circle pi r squared? Right? That's the whole circle. Pi r squared is the whole circle. We know that number is 900 pi times m out of 360. So the only thing missing is the letter m. So think about this. Let's say you're the letter m, right? What are we doing to you? If you're m, what are we doing to you? We're dividing by 360, multiplying by 900 pi. We need to undo that. So to undo it, we do the opposite operation in the opposite order. So we divide by 900 pi, cancels out over here, and we do times 360, cancels out, and we're left with m, and then over here we have all this. Well, the pi's cancel out, the zeros cancel out, so really this is 360 divided by 9, and that's going to be 40. So there's a few ways you could have thought about it, but here we are. That is the answer. Next question, it says ABCD is a rhombus, so let's keep that in mind, that diamond type shape is in fact a rhombus. GEFD is a rectangle, got it. So we know all those corners are 90 degrees. Opposite sides are equal. All right, BD is 12. Since it's a rhombus, it's going to cut into 6 and 6. AC is 8. It's going to cut into 4 and 4. And I notice this tick mark has a 4, so this would also be a 4 because they have the same tick mark. The shaded region has an area of 33. Find the length of DF. Okay. So there is more than one way to do this. The way I would think about it is I would focus on this blue trapezoid that we know the area of. So if I'm focusing on the trapezoid, what is the area of a trapezoid? It is base 1 plus base 2 divided by 2 times the height. What are the things that we know? We know the area is 33. We know that the height is 6. How do I know that? Because this is 6, and it would be the same number here because it's a rectangle across. Remember, they told us that. So we need to think about the bases. Let's focus on the bases. What I would actually do here is call this base x. That would make this base 8 plus x because we have 4 and 4 and x, right? From here would be 4, from here would be 4, and then we said that middle space is x. So the entire bottom in this case would be 8 plus x if we did it this way. So base 1 would be x plus base 2 would be x plus 8. This is our setup. So if I clean this up, 6 divided by 2, this would be 3. X plus x, that would be 2x plus 8. If I divide the 3 over, I get 11 equals 2x plus 8. So 3 equals 2x, x equals 3 halves. And we're looking for DF. Well, DF would equal 8 plus 3 halves, which is 19 halves. That's a 2. 19 halves. Boop. 19 halves, or 9.5. Got it. Pretty cool problem. The following figure can be described as a regular pentagon with a rhombus and triangle attached. Okay, I see them. I see them all. If the apothem of the pentagon is 5, so apothem is from the center to the midpoint. So they're saying that this is 5 over tan 36. Find the area of the shaded region. Okay. So what I'm going to do first is focus on this red right triangle. I'm going to pull it out down here. So I'm going to work on the pentagon first. I have a red right triangle. Now what do? So we've worked these problems before. We know that the top angle is 360 divided by 10. That would be 36. Why 10? 10 of these triangles would fit inside the pentagon. I'm not going to draw a 10, but if you went around, there would be 10 of them. 10 triangles. Okay. And we know that this side is 5 divided by tan 36. If you got a keen eye, if this is 36 degrees, you might be able to quickly know that this side is 5. But let's pretend we don't know that. So let's call it x. So we would set this up. This would be the tangent of 36 equals x divided by 5 over tan 36. So I multiply by 5 over tan 36. Over here, that would cancel it out. The tan 36s cancel out, and I am left with the 5 that we said a moment ago. So I know that side's 5. But that's not the question. But we know that this is 5, which makes this 5. So this entire side is 10. That means that every side is 10, so that's 10. They told us that that shape is a rhombus over here. So now all of these are 10. So we got a lot of 10s. Our goal is the area of this triangle, so we got to focus real hard on the triangle. Right now, if I redraw that triangle, look something like this. We have 10 and 10, and I need that angle up here. I really do, and we can get it. If this corner is 36, wouldn't this be 54? This is a lot of thinking, but we can get there. We know that the radius cuts the corner in half. The corner is cut in half. So this would also be 54. So if I kind of break it out, basically what we have here is 108. 50 plus 54 is 108. That means the one next to it is 72. Well, a rhombus, we know that these are equal, so this is also 72, which means this is also 108, because that's another linear pair. So our triangle has a 108 here. Now, I don't like looking at it sideways like that, so I'm going to draw where the 108 is at the top. So we have 10 and 10, and then what I'm going to actually do is splice it with a height, making it 54 and 54. I need the area of the red triangle. So I'm going to call this x and y. And I know that the sine of 54 equals x over 10. So x is 10 sine 54. And then I know that the cosine of 54 would equal y over 10. So y equals 10 cosine 54. So this number, so we know that this number is this, and that the height is this. So we can now find the area of that triangle. We now know, so what do we have here? We have one, kind of running out of room. I'll do it way up high. Let's go. So the area of the triangle would equal 1/2 times the base. Well, if this is 10 sine 54, the entire thing would be 20 sine 54. Remember, we want the entire triangle. So that'd be 20 sine 54 times the height would be 10 cosine 54. Well, multiply that. 1/2 times 10 is 10. Times 10 is 100. That'd be 100 sine 54 cosine 54. Type that in. 100 times the sine of 54 times the cosine of 54. And I get 47.553. And there's our answer. So 47.553. I like that question a lot. All right, the following is a circle with an inscribed decagon. Decagon, that's 10 sides. The radius of the circle is 12. What percent of the circle is not covered by the decagon? So drawing the most useful radius is the real key here. If I draw this radius, I'm drawing the radius of the circle and the decagon simultaneously. So I'm going to work on the circle first. The area of a circle is pi r squared. That would be pi times 12 squared. That would be 144 pi. That's the circle. The decagon is going to be a little bit tougher. I need to work on this blue right triangle for the decagon. So to work on the decagon, we need that right triangle. We know that we have a radius of 12. This angle at the top would be 360 divided by 20. Theta is going to be 360 divided by 20, which is 18 degrees. And I need both the base and the apothem. I need both of those sides. 12 is not the base or the height. I need A and X. So I will solve for X first. That would be the sine of 18 equals X over 12. So X equals 12 sine 18. I will solve for A second. That would be the cosine of 18 equals A over 12. So A is 12 cosine 18. So this final answer is 1/2 times the base, 12 sine 18, times the height, 12 cosine 18, and it's a decagon, so there would be 20 of them. And if I multiply that out, 12 times 12 times 10 would be 1440 sine 18 cosine 18. Okay, so I want the area of I want the percentage not covered by the decagon. So the percentage will equal, we're going to do decagon, sorry, no, we're not. We need to do the circle minus the decagon divided by the circle times 100. Remember, it's the part we want, which is the space between. We need to do divided by the total. So it's going to be 144 pi minus 1440 sine 18 cosine 18 divided by 144 pi times 100. So let me type all this in. 144 pi, use the pi key, minus 1440 sine 18 times cosine 18 all over 144 pi times 100. And I get 6.451. Perfect. Like it. I love it. I want some more of it. Okay, next question, a parallelogram. So the area of a parallelogram is base times height. But we don't have any heights here, guys. Heights make right angles. If you have no rights, you have no heights. You got to fight for your height. So let's fight for this height. Come on. Drop it like it's height. 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 Let's go. I'm going to call it H, just for height, just for fun. So if I'm working on that blue right triangle, I would have 12, H, and 50, and I need this, and I need H. So that would be the sine of 50 equals H over 12. So H equals 12 sine 50. So the area, and this base would be 20, right? The opposite sides are equal. So this is 20. So the area equals the base 20 times the height 12 sine 50. Well, that'd be 240 sine 50. And that would be the area of the parallelogram. Oh, wait. Find the area of the triangle. Sorry. Well, this triangle ABD would be exactly half of that parallelogram. It's just the diagonal. The diagonal cuts it in half. So I actually need to divide that by 2. So we're at 120 sine 50. So 120 sine 50 is 91.925. 91.925. That's the final answer. All right, one more on here. Let's see what we got. 6 congruent circles are inside the rectangle. What percentage of the rectangle is not covered by circles if AD is 48? So this side's 48. There's a lot of blue already. This side's 48. Now I want you to picture these circles stacked. Here's 1 radius. Here's 2, 3, and 4. So if it takes 4 of them to fill in all 48, what is the actual length of the radius? It's going to be 12. So if we're talking about the circles, area equals pi r squared, but there's 6 of them. 1, 2, 3, 4, 5, 6 circles. So that would be pi times 12 squared times 6. That'd be 144 times 6. That's going to be, the area of the 6 circles is 864 pi. How about the rectangle? Well, how many does it take to go this way? 1, 2, 3, 4, 5, 6. So 6 times 12, this would have to be 72. 6 times 12 is 72. So the rectangle is going to be, its base times height, it's going to be 48 times 72. And that's going to be 3, 4, 5, 6. So how do we get the percent not covered by circles? We're going to do rectangle minus circles divided by rectangle times 100. That's the part we want, right? We want everything that's not a circle divided by the total. So for this problem, that's going to be 3, 4, 5, 6 minus 864 pi divided by 3, 4, 5, 6 times 100. 3, 4, 5, 6 minus 864 pi divided by 3, 4, 5, 6 times 100 is 21.460. And that's our final answer. All right, guys. Those were a lot of fun. Hopefully you're listening and paying attention and you figure out how to do these. I'll see you next time.